All right, so this is the diagram that is used to prove the compound angle formula for cos A plus B. All right, here's how it starts out. I would start out by looking at, let us say, this right angle triangle. Start out by looking at that right angle triangle. And from that, I can say that PR would be equal to PQ, the cosine of the angle, which is A plus B. So PQ is equal to the cosine of the angle. The cosine of the angle, PR is equal to PQ, the cosine of the angle, which is A plus B. And of course, as I said before, you can prove that using Pythagoras theorem. Not Pythagoras theorem, trig ratio. Make this a little bit bigger. Now, PR is also equal to PT minus RT. PR is also equal to PT minus RT. Now, PT is equal to PS, the cosine of A, is equal to PS, the cosine of A, and now minus RT. Let us see what RT is equal to. I could say that RT is equal to SN. RT is equal to SN. No. SN is QS. QS, the sine of A. SN is QS, the sine of A. So this is PS, the cosine of A, minus QS, the sine of A. All right, so we have PS. Here's what I know. I also know that PS is equal to PQ, the cosine of B. And I need to know that QS is equal to PQ, the sine of B. So now I can say PR is equal to PS cos A minus QS sine A, which is equal to PQ, because PS is PQ cos B cos A minus QS, which is what? PQ sine B sine A. So now PR up here at 1 and PR down here at 2 are equal. So it means that PQ cos A plus B is equal to PQ, let's say cos A cos B minus PQ sine A sine B. And so if I divide now the entire equation by PQ, I'm going to get that cos A plus B is equal to cos A cos B minus sine A sine B. And this is your compound angle formula. And what we just went through is the process you would go through to prove it to be true. Now, there's another side of the compound angle formula. This is also true that cos A minus B is equal to cos A cos B plus sine A sine B. Now we can prove this. Let's call this 3. We can prove, let's call this 4. We can prove 4 is true using 3. We can prove 4 is true using 3. Here's how we would go about it. I can say that cos A minus B would be the same as saying cos A plus minus B. So minus A minus B is the same as saying plus minus B. So this would be cos A cos minus B plus sine A, the sine of minus B. Now, this is the same as saying, now I think the cosine of B and the cosine of minus B are the same. The cosine of B and the cosine of minus B are the same. So this is what I'm saying, that cos minus B is equal to cos B. The cosine of the negative of an angle is equal to the cosine of the positive of the angle. So this would be the same as saying cos A cos B. Now, the sine of a negative angle is equal to minus the sine of the positive angle. So sine, let us say minus B, is equal to minus sine B. So this would be plus, let us say, sine A multiplied by minus sine B. So this would be cos A cos B. A positive times a negative is a negative. Sine A sine B. All right. Now all that I've just done, don't go. I made an error, so I just need to fix it quickly. This should have been negative here because we're using 3. Sorry. It's positive here. It's positive here. But if we're using 3, it should have been negative here. Because remember, no, we were using 3 to prove 4. So this should have been a negative here, a negative here. And now a negative times a negative is a positive. Because we're using 3, remember with 3, so our starting point was 3. We're using 3 to prove 4. So this is 3. And we ended up with what? Cos A minus B is equal to cos A cos B plus sine A sine B. This is another compound angle formula. and this is 4, and we just use 3 to prove that 4 is true. Let me bring it down, try and show all of it that you can see it. All right, so this is all of it, and this is how you prove the compound, you prove the expansion, or you prove that the compound formula cos A plus cos B is equal to cos A cos B minus sin A sin B, and cos A minus B is equal to cos A cos B plus sin A sin B.